Welcome back.
Hi everybody, welcome back.
1.5 is transformations.
Yes, this is a little bit more familiar.
Especially if they came from Algebra 2 last year, they probably could teach this lesson.
Probably could. So let's get going.
The one thing they were good at by the end of the year, it was this.
Now, the way that this is a little bit different for pre-calc is that we are going to throw any of the parent functions at you.
All at once.
You have to be really good at the parent functions.
Okay? You have to be able to know where all those points are, where any asymptotes happen to be, and it is time to move them and transform them and do all kinds of fun stuff to them.
Okay. Any key things to remember?
Real quick, what is a transformation? It's a stretch, a shrink, a reflection, or a simple movement left, right, up, down, horizontally, or vertically.
Transformer means change. Okay, it means change.
All right, so the general rule for transformations is inside messes with x's, and you do the opposite. If you are inside your function, you are messing with whatever x was doing, which is a horizontal something, and you do the opposite on the graph
Okay.
than you were doing in the equation.
And the outside would mess with the y's.
Outside y's
But it's not opposite, it's going to do the same.
do the same.
So if you see plus, it really does go up.
So these are called translations for the official vocabulary word. They are simply movements left, right, up, or down. If I have an inside function, I am changing x to x plus c.
Right?
I move which direction?
To the left.
I go left, c. Now you could write it in words, or you could say the original points of the function were x and y. What do they turn into?
Well, x has to go to the left, so x minus c.
There's the opposite idea. Instead of adding c, we subtract c.
And y won't change.
And y stays the same.
Okay.
So what about f of x minus c?
Well, then we must be going to the right.
We go right c. And that means that the original points x and y will turn into
X plus c.
x plus c
And y.
and y. Notice that the inside is opposite when we actually do this on the graph than what it was in the function.
Okay. How about the outside?
Outside the function, if we are adding d outside the function, what do we do to the y values?
It goes up.
It goes up. So we go up d, which would mean the xy points will turn into having the same x's because we did not change the inside.
Correct.
And the y's will then get added to d. We do the same as we did to the function.
Yep.
If we do f of x minus d, it's just simply the opposite. It is down d spaces.
Not the opposite, but it is down d.
Oh, well,
I know what you meant.
all right.
And so then xy will go to x comma y minus d.
All right.
All right, so that's the first row of your chart that's on your table. That's translating, sliding.
Get your own space.
I was sliding. This was me sliding.
All right, what about
There's a song about that.
multiplying or dividing?
Well, multiplication and division turns into a stretch, a shrink, a compression, if you will. And sometimes when you multiply by a negative, it also flips things over. Okay, so we're going to talk about stretching and compressing first.
And this would be flipping over.
Otherwise known as reflection. That's the highly mathematical term. If you care, the highly mathematical term for stretch and shrink is dilation. From geometry, I taught geometry.
All right.
Yeah.
In all of these cases, we're going to assume that a is bigger than 1 and b is bigger than 1. That's going to be important, okay? All right, so what do we got here? I have changed the inside of my function to b times x.
Well, I multiplied it, so I would think it would get bigger. But it's inside, so it's really going to get
Smaller. And so we do the opposite. Now, the best way to think of the opposite of multiplying is going to be multiplying by its reciprocal.
Okay.
It means division, but what we're going to do is we're going to be multiplying by the opposite. So what this is going to make this a horizontal.
Because it's inside.
Yes. And instead of multiplying by b and getting bigger, we're going to get smaller. So it's a shrink by a factor of b. And you got to write that down if you're going to use the words.
Now, if it's a shrink, should we say by a factor of 1 over b?
Oh, yeah, sorry. Screwed that all up, didn't I?
It's all right.
By
You were
a
just
factor
so
of 1 over b. How's
Excited
that?
about your
I
reciprocals.
was. I don't like writing all the words. I like doing it this way.
Okay.
All right, so we're going to take our xy points. We change the insides.
Yes, we do.
So we're going to multiply by 1 over b, which is the reciprocal,
And the y stays the same.
and the y stays the same.
Okay.
That's what I wanted to do.
I know.
All right.
Okay, so then the middle part of your chart here, you've got f of 1 over b times x. So again, it's a reciprocal that you see. So instead of getting smaller, it's really going to get
Bigger.
bigger. So it's a horizontal stretch
Inside's going to be horizontal. Bigger's going to make it stretch.
by a factor of b.
That's what I
You
wrote
can't just
last
say
time.
horizontal stretch. We need to know how much it's stretching by.
And you can't just say stretch. Got to say horizontal.
Correct.
All right, if we use the coordinate points, our original points of x, y, then are going to turn into
bx,
bx,
comma y.
same y.
Okay. If if we stay with the horizontal direction, the inside, what if we multiply by a negative inside?
Well, the negative on the inside means that we're going to use the opposite x's.
Yes, we are.
Well, multiplying by -1 divided by -1, they're all the same, right?
They are.
So where do the opposite x's happen to end up? If I'm on a graph
The
and I'm
other side
over
of the
here,
y.
they end up over here, don't they?
They do.
So this is just the opposite x, so it becomes a reflection
Over the y-axis.
over
Hey, we talked about that a couple days ago.
y-axis. And if you're going to do this with the coordinates, the original x's would then turn into the opposite value,
Comma
and the
y.
y's would stay the same.
Okay.
All right, let's try the other side.
Outside.
If we multiply the outside by a, what do we get?
We get something that's taller.
Taller. So because it's going up and down, it's vertical.
And it's a vertical stretch.
And taller means we're going to stretch it out
By a factor of a.
by a factor of a. Notice we are multiplying by a, just like we did in the problem.
Okay, so xy should go to x comma
Same x,
a times y.
a times y.
Okay.
All right, how about 1 over a times f of x?
Well, that's going to be a vertical shrink
A vertical shrink.
by a factor of. Should I wait and see if you can get it right?
Yeah. 1 over a. Yes. Okay. What means we take our original points. We get the same x value because we're outside our function only.
Yep.
And we have 1 over a times the y values.
Okay.
All right, now our negative sign is outside of our function. Whoa, what's going on there?
Wrong button.
All right, negative's outside our function. So that means we get the opposite what?
Y value.
Y value. So if we have a picture and we have this point here and we have the opposite y values, don't we go this way?
Down there.
Down? So this is going to be a reflection over the x-axis because we have the opposite y's. And if we use our point notation here, we have the same x, but the opposite y.
And again, we don't care if you use the words to identify the transformation or if you use the point notation. It doesn't matter to us. Just make sure you can identify all the things going on to the function.
You're on video, so you're all right. Okay, so important note. Make sure you do what first?
You have to stretch.
You got to stretch or shrink or
Reflect.
reflect before you do what?
Before you slide.
Before you slide.
It's hard to slide in football.
Slide means move up, down, left. Well, that's right. Or left.
Say hi.
Up, down, left, or right. Say hi to Mrs. Martinez.
Where am I? You're over there.
You're over there.
Say
She's
hi.
a little lost. It's her first time. It's okay. All right. Moving along.
Example 2.
Let's do this. You want to graph this one?
Yes, I'll do example 2.
All right,
Okay.
You're up.
So on
Example
example
two,
2, you have this
one.
weird picture with these extra dots. Okay. There's 4 dots here. And all we need to do is we need to do f of x minus 3 plus 2. So the minus 3 is inside, which means we're going to be what direction?
Well, we're going to do the opposite of the minus. We're going to plus. We're going to go right.
Okay, horizontal. So
Oh,
thank
sorry.
you. We're going to go right 3.
I wasn't listening.
That's all right. And the plus 2 is going to go
Up 2.
up 2. Okay. So for this one, there's nothing fancy, and really the point coordinate notation is a little bit more than you need to go. If you recognize that the picture is going to go right 3 and up 2, just
Think they
take
can do
every
that.
dot and go right 3 up 2.
But the key is you got to do it for every point that's important, right?
Yep.
In this
So
case,
all
you
4
have
of
4
these.
labeled points. With
Good
parent
points.
functions, you're going to have points that you memorize, points that you put in the right place.
They memorize those.
They better by now. It's been at least 2 days since we
So all you
did
got to
it,
do right 3 up 2.
right? All right.
All right. Example 2. What
My
if it gets a
turn.
little more tricky?
Yeah, all right. Well, we have 2 things going on here. We have one going on inside. So if inside we're dividing by 2, what does that really mean I'm
That's
doing?
really going to be a horizontal stretch of 2.
Stretch. All right. So we're going to do a horizontal stretch by 2. And we can write that down. Horizontal stretch
By a factor of 2.
by
Sorry.
a factor. I like the words factor.
He does.
It means multiplying things
That's
together.
calculus stuff.
All right. What is this minus sign out here going to do?
That's going to flip us
We're going to flip or
over
reflect
the x-axis.
over the x-axis because we're going to use the opposite y values, so we're going to go down or up as opposed to left to right.
You know,
Now,
I have to think about that picture every time I have a reflection.
that's how I do it. I actually used to tell myself opposite y's go that way. Okay, all right. So now let me show you one way we could do this with some points. And then the next problem, Mrs. Cofield is going to do it a little differently, but
Okay.
it doesn't matter. Whatever's more comfortable to you.
Show us what you're doing.
So what I'm going to do is I'm going to take all 4 of these original points. I'm going to write them down. So this first point was at -2, 4.
Yes. The next one's at 0, 3.
Thank you.
Next one's at 1, 0.
That's even easier.
And for -1.
All right, so these are our original XY points.
Now, by the way, this strategy only works if you can list the correct points.
Yeah, you gotta have the, so if you didn't memorize your parent function points when you have to do parent functions,
It's a little
it's
challenging.
a little harder, but then again, it's gonna be hard to get the right graph anyway, isn't
Okay,
it?
so what are we going to do to these?
All right, well, if our horizontal stretch by a factor of 2 means we're gonna multiply the x's by 2.
Okay?
Flipping over the y-axis means that we're going to get the opposite, I'm sorry, flipping over the x-axis means we're gonna get the opposite y's.
There you go.
So all you have to do is instead of doing it on the graph and looking at the picture and trying to stretch it by 2 and flip it over, you can just use the coordinate points.
Okay.
Multiply all the x's by 2.
Negative 4.
Negative 4,
Zero.
0, 2, 8.
Okay.
Then do the opposite of all the y values.
Negative 4, negative 3, 0, 1.
Positive 1. Then we just plot those 4 points.
Okay?
Negative 4, negative 4, 1, 2, 3, 4, 1, 2, 3, would be here.
Yeah.
0, negative 3, they can't see me counting on the board. 2, 0.
I was laughing because I was thinking up.
1, 2, 3, 4, 5, 6, 7, 8, positive 1. So our
Okay.
new graph is
Connect
going
the
to
dots.
look like this.
Woohoo!
And hopefully you can see that if you stretch this thing horizontally by a factor of 2 and flipped it over, that's where you did that.
Okay.
All right? Now
So-
for a different approach.
Again, you can use the coordinates. Here's another strategy, and we'll use this strategy later on second semester, but for right now, here's an introduction to it. Okay? One more thing I need you to notice really quickly. This letter C has a little bit different notation. Notice it's got all this stuff inside.
All of it's
Okay?
inside.
This is the last time you will see it written out for you that nicely. Okay, example 3 is different, so we'll get there in just a second. But I've got all this stuff going on inside. So what is this plus 3 going to do?
Gonna go left 3.
It's going to go left 3. And a minute ago on example A, to go left 3, I just moved all the dots, right? Okay, what is this little timesing by 2 going to do?
Well, we're going to multiply by 1/2, which means we're going to horizontally
Mm-hmm.
shrink by a half. A factor of 1/2.
Okay. Now,
Left off
I'm
my
still going to
favorite word.
use Mr. Lucky's strategy with all of my stretching and shrinking and flipping.
Remember
I call
earlier
this,
we said we had to do that first.
yes, you have to stretch before you can slide. Okay, so you have to do all of your stretching first. I'm going to do all this, and I'm going to make something called the modified parent.
That word will come up again second semester a lot when we graph trig functions. So
And that looks like modified parent, but it's really 2 words. So we're
Like-
going to take all those same ordered pairs that Mr. Lucky just had,
L in
which
the middle
were
P, or actually a bunch of different letters.
back to kindergarten.
All right.
All right, what are my dots?
So my original points were negative 2, 4,
Okay,
0, 3,
okay.
1, 0, and 4, negative 1. It
didn't-
helps if you can read the graph.
You didn't mess up the dots, did you?
Shush you.
All right, so we have to multiply all the horizontal numbers by a factor of a third. This is the exact same thing Mr. Lucky just did. The difference is I like to slide separately. I'm high maintenance. Okay, so I need a third of negative 2. Stop nodding.
Negative 2/3. Same
I
Y.
know you're nodding.
Not
What's
me.
a third
I
of
would.
0?
0 still.
Oh, okay, cool.
Same
What's
Y.
a third of 1?
1/3. 0.
Same Y,
4/3.
which is just 1 and 1/3.
Yeah, you know that.
I do.
Negative 1.
Got it. My head was in the way. Okay, so what I'm going to do is I'm going to go ahead and graph these dots on my graph. So negative 2/3 and then 4. Be right about there. It's supposed to be 2/3.
Yeah, that's
0,
not really a
3.
negative 2/3, is it?
He's. Why do you make me draw pictures when I can't? I'm going to make you come to my class and draw on my airliner.
I
Is that
can't-
better?
That's better.
Okay. And then we have 1/3, which is way right there. You can see it. And 4/3 is 1 and 1/3.
And
And
negative 1.
-1. Okay. So this red
Is
one
the-
is not the answer. It's the modified parent, which is a little bit challenging to see. But now all I have to do is take all those dots
And move them.
and move them left 3.
Just make sure you count full boxes.
Okay. So I was a little bit before the first box, and now I'm going to go 1, 2, 3, a little bit before this box. Okay.
Yay.
I was right on the axis, 1, 2, 3. Now I'm still right on the axis. I was 1/3 away from the axis. Now I'm going to go 1, 2, 3. I'm still 1/3 away. Okay. I was 1 and 1/3 boxes away. I'm going to go 1, 2, 3. Once again, you can't see me counting. Come see me if you need help.
And the board's a little off, but those beginning and ending dots are supposed to be not quite at the right places.
Yeah, they're not on the hash marks. They're a third away. Okay? So that's another strategy that you can use if that's easier.
Okay.
Alrighty.
Your choice.
Okay. So now we need to talk about this notation with this 2 out
You're up
front.
still.
Okay, with this 2 out front, notice that's a little bit different than what we have written here. Now, a minute ago, we kind of glazed through it, but a few slides ago, we had, there it was, this thing. Okay, well, what is that thing?
That was all the places A, B, C, and D could show up.
Yep, and they're all in there together, okay? Notice in this notation that we have b times x plus c. So that means that we need to have the horizontal stretch and shrink different from the horizontal translation.
Have to factor it away.
It's not different right now, okay? So we need to get rid of this. We need the 3 separate from the slide. So if I factor a 3 out of x minus 6, what am I going to get?
Well, I get that.
I'm going to get x minus 2. So the horizontal translation is not 6, it's 2.
It's just 2. So now it fits
Okay.
our rules.
So we're going to go right 2.
And we'll do some more of this in class.
A lot, okay? In fact, example C on the last example is probably the last time we will have factored it out for you. Okay? What if I
Aren't we
see
nice?
a timesing by 3 inside?
Well, that's a horizontal because it's inside. And it's going to be, instead of multiplying by 3, we're going to multiply the x's by a factor of 1/3.
Yep. I forgot to write by a factor.
Yeah,
I'm sorry.
we'll
Okay, now the other thing that's different about this problem is there's no dots.
Uh-oh. We have to have a parent function.
Okay, what was our parent function?
What was the square root function?
Okay.
Y equals the square root of x. And we have to remember that they had a specific points they had to graph for that.
Okay, so the square root of x had some specific ordered pairs. I'm
0,
going to
0.
write this down here.
0, 0,
I forgot what I was writing for a second.
1, 1,
1, 1,
and 4, 2.
and 4, 2.
And any more you want, it's fine, but those 3 are minimal.
I'm going to go ahead and write 9, 3 as well.
Fair enough.
Because I know I'm taking a third. It's easier to take a third of 9 than it is 4. All right, so now, again, to do our modified parent, all I have to do is multiply all of our x values, okay,
By a third.
by a third.
Now, she's doing it the way she did the last one. She's going to
Okay.
just
Take care of the multiply and the stretch and flip first.
stretch, shrink, and flip. So all she's doing now is taking a third of all the x's, which is 0 over 3, 1 over 3, 4 over 3, and 9 over 3.
Okay, and then I'm going to go ahead and graph those. Now it's going to give me my modified parent right over here. So 1/3, comma 1. That's a third, I promise. 1 and 1/3, comma 2.
How'd you get all the nasty fraction ones?
I just took a third times. Okay, so I did 1 over 3 times 1 over 1.
All right, now, what does she got to do with it?
Okay, now this, again, is my modified parent. The board's off a little bit.
The square root function.
Okay, so what are we going to do with all of them? We're going to take them all and move them
Right, 2 spaces.
So right 2 would be and a
No.
third.
No, you went way too far.
Let's go right 2 from the green dot that was already there,
There you
and
go.
not from whatever I was doing. There we
When
go.
you're doing
right
this
2.
with a pencil, it should be obvious it's not hitting the graph, but we're technologically hampered here.
And this would be right
2
there.
spaces.
This one actually does hit because it's right on 3. 3 away from this dot.
When
And
you
there's
get
your
these graded, you're going to be graded on whether or not your dots are in the right places. So be very careful with
Yeah.
your pencil. All right,
Alrighty.
last one.
Okay.
I'm up. Now, these 2 problems are marked on your notes as the most often missed problems of all, primarily because they don't separate what's going on.
They don't.
Okay, this one would probably be even on the next level up as far as more people get A right once they get the hang of separating them than they
Right.
get B right because there's no number in front of X except for a minus sign.
Yeah, that's confusing.
All right, so what we're going to do to make this problem easier to begin with is we're going to rewrite this as the log base 3 of negative x plus 5. So that you can see that there's actually a B value and a C value in this problem.
Oh, so there's multiplying by -1. So we still have to factor that out.
We must factor, well, we have, look at your learning targets. It says, there's only 2 of them. The second one says, know how to handle a horizontal stretch and shrink along with a horizontal translation. And this is how you
So
handle
this
it.
is hugely important. People in calculus are missing this problem on the AP Calc exam.
Oh, bunch. Well, okay, so log base 3
And Mr. Licky knows because he grades them.
minus sign gets factored out. That's really
Okay.
a -1 if you want to make it that way.
Okay?
Parentheses, that would be a positive x
Minus.
minus 5.
All right.
All right, so now I'm going to do it the way I did my problem earlier.
The ordered pairs.
With the ordered pairs. And what we've got here is we have a horizontal multiplying by -1,
So that's
which
gonna
is a
flip.
reflection over the
Y-axis.
y-axis. So this is just going to make the x's opposite, and this is going to make it plus 5, if you will. So the xy, the original x's are going to get multiplied by -1,
Okay?
and then we're going to add 5 to them.
To make them go to the right.
There's nothing outside of my function,
Nothing
so I get
going
the
on.
same y.
So what's that 3?
Well, this is the base of our logarithm. And again, we're back to our parent
Logarithm.
functions.
Okay.
Real quick refresher, a logarithm of base b has two important points in a vertical asymptote.
It does.
Its points are
1, 0.
1, 0, not 0, 1. Then whatever the base turned out to be, comma 1.
Correct.
And then there was a vertical asymptote at
At
x
x
equals 0.
Okay.
Notice it's an x value,
Which means it's vertical.
which means I'm going to change things as well. But here we go.
Does asymptotes change the exact same way that ordered pairs change?
So here's what we got. Our base is 3, so our 3 points are 1, comma 0, 3, comma 1, and we still have a vertical asymptote at x equals 0.
Okay?
So all we're going to do in this problem is take the opposite of x and add 5 to it.
Okay?
The y's are all going to stay the same. All right?
All right.
So if we take the opposite of 1,
That's -1.
add 5,
That's 4.
we get 4. If we take the opposite of 3,
That's -3.
plus 5
Is 2.
is 2.
I like this math.
And this x value is 0, so we take the opposite of 0, which is,
0
and add 5.
plus 5.
So we now have a vertical asymptote at x equals 5.
Okay.
And these are the three things we must have on our logarithm function to get credit.
So let's go ahead and graph them.
So 1, 2, 3, 4, 5 on the x-axis means that we're going to have a vertical asymptote right here.
Okay.
We're going to have a point at 4, 0.
Notice that's not touching the vertical asymptote.
Then we have another point at 2, 1.
When we tell you things like notice, that's because a lot of students have missed them in past years.
Nobody misses these problems, do
Yeah,
they?
and it's a logarithm, so it kind of goes.
Now remember, this thing got flipped over the y-axis, so instead of it going 1 to the right, it's now going over here to the left, and it's going to look like this. If you want to be more accurate, find more points. But for us, for right now, that's going to do it for
That's
us.
3 things.
Okay?
Alrighty, so we will see you in class where we